Hello, this is Mr. Doro. Today we're going to be talking about calculating percent yield. This is another aspect of stoichiometry. It sounds kind of difficult because there's some new terms in here like actual yield and theoretical yield and percent yield. But really it just comes down to figuring out percentage. What you get, what you expected to get, and then finding the percentage of that. For example, if you were to take a test and you got 84 out of 94, in order to find that percentage, you just do 84 divided by 94 times 100, and when you do that, you get 89%. Hey, you did a nice job. You must have studied. And so that's the same kind of stuff that we're going to be doing for percent yield. So this is the formula for percent yield. You have to have this written down. Percent yield is going to be actual yield over theoretical yield times 100. So we got to talk about what these terms mean. First of all, this actual yield. Actual means what you actually get in the lab or was actually produced. So you're looking for words like in the lab, if you see that, or was produced. You actually made that. You came out with that. The actual, like on your test, would be the score that you got. Theoretical yield is a little bit different. Theoretical is what the possible amount was on your test to be, how much it was out of. But theoretical, when we're talking about these reactions, is going to be what you calculated on an action line. So you calculate this, you say I should get this much, and when we do an action line, we're going to be also always calculating the theoretical yield. So this is a typical problem that you might see for percent yield. What is the percent yield of water when 30 grams of sulfuric acid reacts with excess? Now that word excess is telling you that this is the excess reactant. You have extra aluminum hydroxide. You don't need to find the limiting reactant. They're already telling you the other reactant is the limiting reactant, and produces 10.6 grams of water in the lab. So that 10.6 we're going to use here in just a minute, but this is the skeleton equation, and you have to balance the equation. So why don't you stop it right now and go ahead and balance it. Alright, that one was kind of a stinker to balance. You had to think of that H2O as HOH, at least that's the best way I can think of to do it. So when it says percent yield, remember that percent yield is equal to the actual over the theoretical times 100. Now up here in our problem, we already have what the actual is. You see how it says in the lab right here? That is our actual yield of water, and that usually has to be given to you, or you have to find it in the lab. So our actual, when we want to do percent yield, is going to be 10.6 grams of water. But we don't know our theoretical, and then if we don't know that, we can't find our percent yield. So to find theoretical, remember, to do that, we have to do an action line. We're starting out with 30 grams of this stuff, and we want to know theoretically how much water, if all that reacted, should that make. So here we go. We're going to do an action line to find that out. 30.0 grams of H2SO4. And then we're going to change that grams to moles, and that molar mass is 98.09 grams. And that's 1 mole of H2SO4. And this is H2SO4. And then we're going to go from moles of H2SO4 to moles of water, because that's where we want to get to. We want to find the theoretical yield of water, H2O. So that's 6 from the balanced equation and 3 there. And then we continue on to find our grams of H2O. So we got moles of H2O, grams of H2O, and 1 mole is 18.02 from the periodic table. And then I end up with, when I calculate that all out, 11.0 grams of H2O. Now that is, right there, is my theoretical yield. Theoretical yield. In theory, if all that reacted on paper, I'm saying I should get 11 grams. So that goes down here where the theoretical yield is, 11.0 grams, and then times 100. I calculate all that out, and this is what I end up with. I end up with 96.4% yield of H2O. And so what that means is that I got 96.4% of what I thought I should get when I calculated it out. That's a pretty good yield. And so those yields should not be higher than, although they could be if you made a mistake, they could be higher than your theoretical yield. Alright, so here's a little bit different type of problem, still dealing with percent yield. It says that coal gasification is a process That converts coal into methane gas. This is the chemical equation for it. If the reaction has a percent yield, that's giving you percent yield right there, 85%. What mass of methane can be obtained from 1,250 grams of carbon, assuming sufficient water is available? So there's enough water, that's our excess reactant. The 1,250 grams of carbon is going to determine how much methane. That's the methane right over here. So this is a percent yield problem. So remember, percent yield equals actual over theoretical times 100, and we know the percent yield in this case is 85.00%, and then we don't know our actual and we don't know our theoretical. We're going to solve for actual, but we can find theoretical first. Theoretical goes like this. It starts out with 1,250 grams of carbon, and we can figure out how much theoretically CH4 we should make. So we start with 1,250 grams of carbon, and then we do a mass-to-mass action line, grams of carbon to moles of carbon, and that's 1 mole is 12.01 grams, and then moving on, we go from moles of carbon to moles of CH4, and that's a 1 to 2 ratio, and then now we're at CH4, so we can go to from moles of CH4 to grams of CH4. And 1 mole is, according to our periodic table, 16.05 grams. And then when we calculate that all out, we find out that we should make 835 grams of CH4. I know that's not in scientific notation, but that's not what the answer is. That's just to get to the answer. So down here for the theoretical, it's 835 grams of CH4. And so that's also times 100. So in order to solve for actual, what I need to do is get this A all by itself, the actual all by itself. So I'm going to multiply both sides by 835 grams. That cancels that out when I multiply them both by that, 835. And then I'm going to divide both sides by 100. So divided by 100, divided by 100, cancels that out. So I get A equals, this is what it ends up, 835 times 85.00, that percent will be taken care of, divided by 100. And when I plug that in my handy dandy calculator, I get 709.75, and that is my actual yield that I'll get out of this, 709.75 grams of CH4. Now, that's not in scientific notation, though, or sig figs, so I need 3 sig figs. That would be 7.10 times 10 to the second grams of CH4. So a little different way there to work this out, but it's still all dealing with percent yield. So here's a problem just like that last one that I want you to do. Percent yield for phosphorus pentachloride, that's this stuff right up here, phosphorus pentachloride, is 83.2%. What mass of PCl5 is expected from the reaction of 73.7 grams PCl3 with excess chlorine? So you start with 73.7 grams of this, figure out how much of this you should make, that's your theoretical yield. And then this is your percent yield, you're going to solve for actual yield. So I want you to do that one. That's an action line and then the percent yield problem. And the answer that you should end up with is 93.2 grams of PCl5. See if you can get that. And now I got one more problem for you to do. I've given you a balanced equation. I'm telling you that you're starting out with 79.6 grams of hydrogen. 79.6 grams of hydrogen. You have excess nitrogen, so we really don't care. We got plenty of that stuff. I want you to find out what this is, how much of this you should yield, the NH3. That would be your theoretical yield, so that's an action line. One action line to do that. And then it says, what is the percent yield? So remember, percent yield is actual over theoretical times 100. To produce that much, this is how much I want to make. This one right here is my actual yield. So that goes in for actual when I do this. Percent yield equals actual over theoretical times 100. Remember, you're getting your theoretical from right up here. When you solve for this, that is your theoretical. This is your actual. You need to do an action line first. Your answer that you should end up with is 77.9%. See if you can get that. If you don't know how to do it, go back and watch the 3 slides ago when we went through all this stuff. Don't just say I don't get it, because they're back there. Watch it, listen to it, follow those same steps. Have a great day.